about. A majority of them of the studies are on my PhD, but there's a few pilot studies that were kind of motivated by questions that came out of that, and then another study that I had been involved in subsequent to my PhD. I'm not actually really going to talk about it at all, what I'm working at the moment, but you can ask me about that if you want. So I hope now I'll try and go faster in the areas because it might be too basic or a presentation, but I'll go through it quite quickly. So obviously you know that the population is growing, and the people over 60 are expected to double by 2050. So this is a massive medical achievement, obviously we all know, but it is a challenge to maintain a high quality of life as we age, in particular given the mobility problems and possible cognitive decline as we age. In fact, the biggest limiting factor to independence in older adults is impaired cognitive function. And most studies show dementia to increase, in fact some studies to triple by 2050. So this is a massive problem. And we do know that there are less severe earlier stage forms of dementia, such as mild cognitive impairment, and diagnosis in this stage increases the effectiveness of interventions and increases treatment options available. So what is most pertinent is to be able to detect transitions from this healthy, benign, successful aging into mild cognitive impairment. It is very important that we are able to understand the generation and maintenance of health in addition to detecting these subtle changes. But this is obviously very difficult given the cognitive decline and compensatory strategies that may also be a factor within this population. I don't know how much you know here of the neuropsychological assessments, but just very quickly, that obviously neuropsychological assessment tests are one gold standard in assessing cognitive function. There are obviously different tests, but two assessment tests for global cognition are the New Mental State Examination, or MMSE, and the Montreal Cognitive Assessment, or MOCA. They're both 0 to 30 point tests for global cognition, and they both have a total score and then individual domain scores, but MOCA also has sub-scores. MOCA has a greater executive component, and it is possibly due to this found to be more sensitive to mild cognitive impairment. These assessments of global cognition are based on normative values with validated standard cutoff scores for these global assessment tests. But these can be subjective. They are dependent on the administrator, on language of the administrator, and on the language of the participant, and as well on education, on depression, on mood, on fatigue, on also on the sensory impairments that may exist within this population. And also normative values which these tests are based on are usually based on a population between 65 to 85 years of age, which so if you don't fit in this bracket, it's hard to assess the person. So these objective measures are needed, and they need to be validated in a wider age range. And if we could come up with these objective measures, we may have potential to expose preclinical symptoms. As a lot of people know, everyone knows here, so as we age, our gait changes, so our gait slows, our step length decreases, and that these changes are associated with functional change, such as multiple falls, survival rate, and reduction in activities of daily living. But what does this mean? What do these adaptations, perhaps adaptations, mean? Is it a generalized slowing of processes due to normal aging? Is it an adaptation to maintain stability, or are they possibly biomarkers for cognitive impairment or another impairment? Within literature, this is backed up by the fact that poor performance is associated with an increased risk of falls. That this is poor performance in both global cognitive function assessment tests as well as specific elements of cognitive function. Lower cognition is linked to reduced gait speed in both healthy and cognitively impaired cohorts, and it increases with higher attention demanding tasks, as we know here using the dual task. In addition, this whole idea of gait automaticity and moving from to a more consciously controlled gait, possibly with maybe more prefrontal involvement in gait. And this is linked to cognitive performance, cognitive reserve, and costs of performing a dual task. In addition, gait variability is being linked to neurological diseases, falls, and also with complexity of gait task. So, I suppose really culminating from this, it would be beneficial to probe cognitive contributions to gait in a healthy natural representative cohort. It is of interest to probe global cognition in addition to specific elements of cognitive function. Those that are found in literature, such as speed of processing, memory, as well as, and in particular, executive function and attention. Key factors of interest are transition from automatic gait to this more consciously controlled gait, and what controls that, and assessment of both cognition or cognitive function and gait, and improvements in attentional capacity. And then how does this change with age, how does this change with task, and with many covariates that exist, in particularly in older or disease cohorts. So in the TILDA dataset, in my PhD, I had several aims, and as I said, that was based on the TILDA dataset, but there are other pilot studies that I would like to talk to as well. Mainly looking at gait speed differences over executive function spectrum within a population, contribution of specific elements of cognitive function to gait speed, as I mentioned before, speed of processing, short-term memory, and executive function have been highlighted a lot in literature, but also look at the effect of age, the effect of gait task, and the effect of global cognition on the contributions of specific elements of cognitive function to gait speed. And then look at gait variability differences across attention spectrum in the population. This hasn't been fully explored, and I hypothesize that cognitive processes will be specifically recruited for gait, and that these cognitive processes would be dependent on the task performed. So the TILDA dataset is a large dataset. It tracks participants resident in Ireland over 50 years of age. It tracks their social, health and economic circumstances, and is in its year 3 or wave 3, and it will continue hopefully with funding for 10 years. So a lot of this data is on cross-sectional analysis, and using the gait information from the gait assessment as well as the neuropsychological assessment. So during the gait assessment there were 3 gait tasks, one single task which involved participants walking up and down a gait right mat, so 2 passes average of the gait right mat, in addition to a dual cognitive task which was walking while reciting alternate letters of the alphabet, and a dual motor gait task which was walking carrying a glass of water filled to 1 inch from the top. And there was, over the 4 hours assessment that each person had within TILDA, they had approximately a 40-minute neuropsychological assessment which assessed global cognition in addition to lots of different specific elements of cognitive function. There were over 8,000 people within TILDA, but and they were all left a questionnaire and asked to attend the health assessment. So 5,000 of them attended the health Most of the analysis was performed using linear regression. However, some ANOVA and Z-scores were also used. So initially, just looking at this massive data set, I wanted to try and get an idea of the variation in cognitive function and gait performance within this data set. And I tried to do some, I suppose, simple analysis, and I found that those TILDA participants were young, considering that it is nationally representative of Irish people 50 years and older, with a mean age of 61.4, I think. So you know, the Irish population is a young population, and they were fast walkers compared to other longitudinal studies and had good global cognition. And there was a higher variation in MoCA compared to MMSE, and partly due to the sensitivity to MoCA to this mild cognitive impairment, or more sensitive to those who have good cognitive impairment. The people that attended the health assessment had different characteristics from those who were asked to were invited to participate in TILDA. So those that attended the health assessment were generally younger, they had better health, they had a higher level of education, and therefore it was quite important to adjust for this if the results were to be nationally representative. Initially, here you see I tried to do some I suppose simple analysis by looking at Z-scores in the TILDA population and breaking people down into different categories. But actually what came from this analysis was that it was just there's too many covariates within this population, and other methods needed to be employed to try and adjust for these covariates. So then in the following studies I used regression, multilinear regression, adjusting for lots of different factors, which were available within a lot of the TILDA questionnaires that the full 8,000 people had answered. So moving on into study 2, I wanted to look at executive function and the difference, the gait speed across this executive function spectrum using a Delta Colour Trails test, and looking at those with poor, intermediate and good executive function, and using the bottom 5% of executive function in the population as poor executive function, and then between that and the medium for intermediate and above the medium for good. I also wanted to see if increasing this poor executive function measure would change any results. So I also looked at tertiles of executive function. And then again, I wanted to parse apart this executive function gait speed relationship, so I also looked at deciles. So a lot of different categorizations here, stick with me. And I looked at gait speed and geotask effect as well. So the main findings were that regardless of executive function scores, gait speed significantly varied with gait task, and we know that is consistent within the literature. And that for both gait tasks, there's a poor executive function had a slower walk. This was robust for covariate adjustment, and it was found for both division and tertile analysis, which was interesting, given that that obviously the tertile, the bottom third of participants had a slower gait than the top third. So you know, even giving a massive amount of the population, this still remained the same. And then looking at decile analysis, so we found that examining here gait speed adjusted for the covariates over 10 deciles of executive function, and here initially we see that yes, there is a difference in gait speed for the different gait tasks. This is the cognitive task, this is the motor, and this is a single gait task, so there's a massive difference. And then here assessing the difference in the top 10% of executive function scores against all the other executive function scores for the cognitive gait task. The bottom 20% of people within this population had a slower gait speed than the top 10%. And I kind of wanted to examine this, because is I was hypothesizing that this perhaps is the start of executive function's effect on gait. And then also looking at the dual task effect, so showing, I suppose, also the difference in measures between gait speed and dual task effect. Is this perhaps a more sensitive way to explain things? And here with the motor gait task, looking at here the bottom 10% of participants here becoming had significantly slower gait speed, and then here the bottom 40% of the population here had significantly correlated executive function and gait speed scores. And so from this really, this initial study, I concluded that in this nationally represented population, the slower gait speed, those with slower gait speed had poor executive function. And that perhaps those with a negligible deficit in gait speed and dual task effect over all gait tasks have a largely automatic gait and possibly more efficient neural recruitment for more complex gait tasks. And I say this, and I do say it later, that perhaps we do need to look at other different dual task measures, that different measures weren't taken into account, but for the moment, I suppose, that was is my hypothesis. So looking at executive function in isolation isn't really the best way to look at things. Looking at independent contributions was perhaps a better way to look at things. So I wanted to see, do other elements of cognitive function hold more information than executive function alone? So I hypothesized, such as in literature, that short-term memory, executive function, processing speed were major contributors to slower gait speed. Taking all measures used within TILDA, and then gait speed during the 3 gait tasks, and dual task difference as well during the dual gait tasks. So finding here that looking at differences in gait speed for one standard deviation difference in neuropsychological test score shows that for both dual tasks, all neuropsychological assessment tests contributed to gait speed. But for the single gait task, only short-term memory here as assessed by immediate recall, processing speed and sustained attention contributed to gait speed. And next I wanted to look at the independent contribution of each of these neuropsychological test scores. And this found that for all gait tasks, short-term memory, processing speed and sustained attention contributed to gait speed. So given the relationship found within all my regression and age being very significant, I decided to look at different age groups and take each of these major contributors to gait speed and break them into tertiles and look at them over these 7 age groups. So showing here that with the cognitive gait task and the motor and the single gait task, showing here different tertiles and of executive function over 7 age groups, showing here that age is a dominant factor in any analysis that we do, and that really this needs to be taken into account of clinically when you're looking at baseline scores and also adjusted for. So I wanted to also look at the difference in gait tasks. So looking here at the dual task difference, or the change in gait speed and the differences for the different tasks. So here we found that there was an additional executive function component found in both dual tasks that wasn't found in the single gait task. So in conclusion, the major cognitive contributors to gait speed in all gait tasks were speed of processing, short-term memory and sustained attention, and these were independent contributions. For the dual gait task, there was an additional executive function element that was not seen for the single gait task, and that standardized validated walking tasks and gait speed outcomes for different age groups are required. And these results may form a baseline for the dual task gait speed in a population over 50 years of age. And sustained attention was highlighted here in addition to the independent contribution of processing speed. So looking at this, I mean, it's all very well having a 40-minute assessment test, but clinically a lot of people use the more global measures of cognitive functions such as MOCA and MMSE. So I wanted to see, was this analysis robust using those more commonly used clinical tests. So I wanted to see how this relationship existed using the MOCA, the Montreal Cognitive Assessment, which is used a lot clinically, and to see if this similar relationship occurred. And I also wanted to see what was the effect of the global cognitive group on this cognitive gait relationship. So I looked at MOCA total score, and then the 8 MOCA domains, and also the 25 MOCA subscores, and looked at gait speed during the dual gait tasks. And showing here that, as I suppose others have shown, that higher global cognition, those with higher global cognition had a faster gait speed, and that for the MOCA domain scores, that for both dual tasks, visual, spatial, executive skills contributed to both gait tasks, in addition to attention, but this wasn't significant for the motor gait task. Language, and for the cognitive gait task, and delayed recall also contributed, in addition to some abstraction for the motor gait task. And then looking at the subscores, just to be thorough, we also found here that there were fluency here contributed to both dual gait tasks, and this is an executive component of language, as well as additional subscores which were specific to tasks. So for the motor gait task, attention MOCA subscores contributed to the motor gait task. So that's while walking while carrying a glass of water, and the trail and the cue contributed to walking while reciting alternate letters of the alphabet. Next, I wanted to see how this relationship changed with global cognitive group, and this was quite interesting. So showing here, looking at those with poor global cognition, intermediate and good global cognition, showing that those with poor global cognition had many MOCA domains associated with slower gait speed. But for those with intermediate global cognition, it was only orientation. And then for those with good global cognition, it was just visuospatial executive scores. So I think really what this study is showing is that those with better global cognition have faster gait speed, yes. But this is regardless of global cognition. Executive function is recruited, cognitive elements, as well as additional cognitive elements specific to the dual gait task. But most importantly, that different global cognitive groups recruit different cognitive elements during motor tasks. And this is important for interventions, which shows that perhaps more personalised interventions are needed. And it may show that those with poor global cognition recruit more varied cognitive processes, or that those with intermediate global cognition have a weaker MOCA domain gait speed correlation. But I suppose we need more robust gait speed measures in order to say that. But it does show, I think, that different strategies and priorities may be employed by different cognitive groups. So next I come on to just a few of the pilot studies. So I mentioned in one of the studies, sustained attention came out. So I wanted to do a bit of work on sustained attention and then on gait variability. So just to go into a little bit of the sustained attention measure here, because I know it's different from the one you use. So the sustained attention measure, 1 to 9 comes up on a screen in sequence, and you have to press a button for every number but the number 3. So this comes up for 4 minutes, so it's quite repetitive. The idea is to have some attentional disengagement. And so the sustained attention measures are the variability in the response time to these numbers, and then also the errors on the number 3. So when you click on the number 3, the two measures usually that you use. So one of the pilot studies looked at sustained attention gait variability. We looked at gait variability in the TILDA dataset. Now, I did talk about this in ISPGR, I think it was 2 years ago now, but actually, given that there was only 2 passes of the gait map, there's questions on this gait variability, and so I didn't look at it further, but there was a relationship between stride time variability, in particularly the response time variation within this task, and those with and attention. In that, those with higher stride time variability had poorer attention. And then moving this study slightly on, I wanted to look at longer measures, longer walks. So we did a little study in one of the hospitals in Dublin, St James's Hospital, and looked at gait variability using codomotion, and found that actually sustained attention was not associated with stride time variability in this population, as you might expect with a healthier population. During any of the tasks, so there was a single task, a reach task, serial 7 task, and we also looked here in this study trying to see if we could examine different measures of gait variability. So we used this Poincare measure, which is used in heart rate variability, and it has different measures within it to examine short-term and long-term variability. And we, I suppose, validated these measures. They found them highly correlated with standard deviation coefficient of variation that we would use, and we're hoping to move this on a bit further. So moving on from this, another pilot study looked at measures of cognition during movement using EEG. So the measure mainly used here is the P3. So what the P3 occurs so 300 milliseconds after you see a stimulus on a screen, the P3 peak will be shown in your EEG data. And a measure of attentional load or decline can be a decrease in the amplitude of this peak, or an increase in the latency. So perhaps in some disease cohorts, this could be at 400, or and then the peak can be down much further here. And in the first study we looked at this, we only used 3 midline electrodes. There's a nose here. We just used 3 midline there. And what's interesting about the P3 is it has been linked to correlated with neuropsychological tests as well. So this is a small little study we did as well, looking at those in trying to, a lot of the work done in our lab is very, very controlled in a dark room. You don't move at all, and you look at a screen. So we were trying to move from the dark room, and then we turned on the lights, and then we went onto the bike, and then we tried to get on the treadmill, and then we tried to walk around the lab. So the treadmill and the walking around the lab didn't work so much with the BioSem EEG behind us. But we did actually, and surprised ourselves, got some information from the control, which was, well, we were expected to get that. It was just a baseline, which is a normal clinical setting. The static, which is sitting down with the lights on, and the cycling. And we found actually these are healthy cohorts, so it's nice data. But we actually found that there wasn't that much difference within these peaks. So we took the difference in the peaks, the variation in the peaks in the different experimental conditions. We took that as the dual task effect. And we found that there was a difference between when someone heard a low tone, and when someone heard a high tone. So their P3 increased, which you would expect. So that was happening. But this didn't, with the amplitude of the peak and the latency of the peak was pretty much the same in all the tasks. So I suppose in a way we thought this validated using EEG with movement, which was brilliant in this young cohort, and that, as we know, performance of a cognitive task, a relatively simple motor task, did not represent a significant dual task effect. And next, this is the last study that I worked on most recently, and I should have lots of slides on this, but I apologise, I don't have videos and things. But basically, this was a European-funded project called VERVE, which was with the Mater Hospital, Professor Tim Lynch there, and a neurologist Conor Fearon as well, who will be at MDS, if anyone's presenting on this work, on a lot of different things within this work, because we were able to jam in a lot of different experiments, which was great. And what actually we did was we had pre and post assessment, and then an intervention, which were 20 minutes, 8 times for over 2 weeks, on Parkinson's disease patients that freeze. And we had a Wii board, we had a screen with a virtual reality, and for the pre-assessment we had EEG as well. Now I'm not going to talk about the EEG data, that's still to be analysed, we have a lot of that data. Things, we didn't do EEG post-assessment because that wouldn't really change, but what we did find was, so we took an awful lot of different measures. It was a Wii board, and we did stepping in place, which was trickier to get information out of, so possibly it might have been a limitation of the study, and if we were doing it again, we'd like to get a much better system. But we set it up in a way where we had single cognitive task, single motor task, and then dual motor task, and a few different other tasks which I'm not mentioning here, which we haven't analysed yet, with cues on the ground and things like that. And then we took, during the pre and post assessment, so the task was a Stroop task on the screen with pressing the button, and there was a modified tug, freezing of gait questionnaire, UPDRS motor, then global cognition, and frontal assessment battery. And so we found just results coming out now that both myself and Conor are Conor Fearon are hoping to publish on, are looking at showing that dual motor. So there was a dual task performance improvement. That's what the results in general showed. That, and particularly this seems to show that this cognitive, this dual motor cognitive virtual reality training improves dual task performance in those participants who freeze when they walk. What it really showed was a lot of the measures at pre-assessment, there was a big difference between those freezers and those with Parkinson's. But during post-assessment, it seemed to show that those with freezers seemed to move up a level into the same level as those with Parkinson's alone. And those with Parkinson's seemed to improve as well. This was quite a small cohort, so there was a lot of variation in improvement and a lot of different measures. But the gait measures did improve, and the difference between those with freezing and those with Parkinson's did reduce. This wasn't significant, but the differences between those with freezing and those with Parkinson's, that did significantly improve. So there was a greater cognitive improvement. And it also shows that, and this is, so this data was submitted actually to, I don't know if you saw that IEEE Health Informatics special issue, So we've submitted this to that. We haven't heard back from that yet. And this is going to be submitted hopefully to movement disorder. So we designed this in a way to be able to take experimental measures and then also be able to see if this translates to clinical measures. So we have shown actually that there was an improvement in the modified TUG after this post-intervention, and that there was a lot of anecdotal evidence from participants saying that their freezing really improved, and also certain questions on the new freezing of gait questionnaire improved, such as amount of time spent freezing a day, and cognitive flexibility, so the Mocker trail scores seem to improve. Now, I suppose Mocker trails can sometimes be quite variable at the best of times, so, but the modified TUG and the freezing of gait questionnaire, I think, shows, and the anecdotal evidence, I think, shows that definitely this whole dual motor cognitive virtual reality training seems to be beneficial to those who freeze and to those with Parkinson's as well. So I suppose bringing all these studies together shows that community dwelling adults over 50 years of age, that various cognitive function elements are required for all gait tasks, regardless. That greater sustained attention, processing speed and short-term memory specifically highlighted to contribute to faster gait speed. But always, I suppose, the question when you are working in this area of research are these common neural processes recruited for both the gait task and the motor task separately, or are they the cognitive resources specifically recruited for gait? And I think actually that these results do show that the gait is not an automatic, that in community dwelling older adults, that indeed cognitive resources are specifically recruited for gait. In addition, I suppose looking at complex gait tasks, and that these results show that cognitive function elements specific to gait tasks are recruited during these complex gait tasks that aren't recruited during single gait tasks. And then does this mean then that complex gait tasks are more suitable to simple gait tasks when investigating cognitive function in community dwelling adults, and also when investigating Parkinson's or those with Parkinson's who freeze? It seems to be that perhaps this increasing attentional capacity maybe occurs to a better degree during these dual gait tasks. And it also opens up the possibility of exploring the clinical efficacy of the dual task paradigm to assess cognitive function clinically. Also, given that I was fortunate to be able to work on the TILDA dataset, this allowed for gait speed differences to be found for specific cognitive performance scores. This is clinically beneficial because it increases our understanding of this gait cognitive function relationship in a community dwelling population, but it also may inform clinical cutoff scores for gait performance for those perhaps in midlife, as TILDA tracks people from 50 years of age, but also in general healthy older adults. And also we looked at specific gait speed and executive function scores, and hypothesized that maybe this link, and I'd love to look at this further, is a transition point from an automatic to a more consciously controlled gait, or maybe a target population for intervention. And I think this is where perhaps gait variability comes in, that looking at executive function as well as gait variability using a long walk, perhaps you could isolate a target population for intervention. And that many factors affect gait performance, and especially in older age and in disease cohorts. Age, task, and global cognition are specifically highlighted. Standardized, validated walking tasks and gait speed outcomes are needed for different age groups. And perhaps personalized intervention protocols are needed for those with different motor performance and different cognitive performance. So in general, these bidirectional links between the executive and the motor activity, and it does probe dual task theories, And I suppose it highlights that further investigation is needed to examine the compensatory strategies during dual gait tasks and the links to global cognition and to possible transitions between that healthy aging to that mild cognitive impairment that I was talking about earlier. There is also the benefit of employing gait speed during specific dual gait tasks to possibly assess cognitive function. So I suppose moving on from this, where is this all going? Ideally, I would like to probe neural processes involved in gait through novel experimental procedures, such as ambulatory EEG, FNIRS, and then also systems like the Karen system, where you can have immersive virtual reality. You can, similar to your lab, you can design, you can track everything all at once and see what comes up, or Vicon. And then also to look at standard and novel gait measures and methods. So looking at, for instance, the Poincaré measure that I used, different measures that are used and different methods that are used within other areas of research, perhaps probing those, but also probing this whole dual task effect. Are we actually, are participants actually performing the dual task simultaneously, or is it, as we saw in some of the Verve study, is it really, could it be the participant walking and then performing the task, walking and then performing the task, and different very easy measures or very easy experimental procedures can be put in place to see if this happens. For instance, speech recording during a dual gait task, and there's been some work done in our lab as well on cognitive function in speech, so that might be an interesting thing as well. And this needs to be applied to late and early stage cognitive impairment, to Alzheimer's disease, and to also to other new emerging age-related pathologies. This seems to be almost like an umbrella term, and perhaps if we keep on probing, we may be able to parse apart what is actually happening and find very early biomarkers for perhaps different forms of cognitive impairment. But poor cognitive performance can be manifested in many ways. Perhaps slowing down when you walk isn't a bad thing. Perhaps it's a really good thing. Perhaps you're prioritizing your walk and therefore you won't fall. We do need to look at the temporal nature of gait, as we're doing at the moment, but also the temporal nature and the rhythmicity of cognitive measures. Perhaps using EEG, perhaps using standardized computer cognitive tasks. And I think if we do that, we'll be able to understand neurological function and the links between the motor and the cognitive processes. But really, in conclusion, the various measures need to be investigated in order to understand the relationship between gait and cognitive function more clearly. And similarly to what you have here, and the enormous amount of data, and I suppose that is something as well we need to cope with, but that you do need to probe at every level, really, and see what comes out. So I'd like to thank you all for listening, and thank you all for a great day. I'd like to thank a few people from the lab as well. That's great.
Thank you very much. So, questions from the audience?
I've got a very simple, basic question. When I was at primary school, on our sports day, we used to have the 100-yard dash, and we just went half 11. But when it came to the egg and spoon race, there were those that had a strategic intervention that decided to go slow and concentrate, and those that threw caution to the wind and then picked the egg up.
Yes. So,
you've obviously, you told your subjects to walk at a normal pace, because I read that in your paper. The others were holding an inch below the top with the water and the glass.
Yes.
But did some go over cautiously slow because they didn't want to spill it, or what? How did you convince them to walk normally?
I mean, that is a limitation. Yeah, I mean, there was written down if the glass, if any water was spilled, but it wasn't. Trying to find a metric for that is quite difficult, and it's definitely a limitation of the study. And I think perhaps finding, a baseline like you have here maybe is the way to go about that, or, as I said, if it's a verbal response, maybe recording that, or you know, trying to align the cognitive with the motor task, trying to align the two performance measures is definitely something that needs to be worked on. And then with the alternate letters as well, how well people did in that. But it's a limitation of the study that I suppose if these things aren't in from the beginning, then it's very hard to take a written note as an accurate result. So it was thought that you know, sometimes it was written, perhaps sometimes it wasn't, so we didn't take it, but it will be brought in future waves of the TILDA study.
The other thing is, just another observation, when you're walking around the hospital with a cup of coffee and you've got extra things in your hand, it depends if your elbow's caught and kind of anchoring it as to whether you've got a free arm as to the stability of your hand at the other end. Is the stability of your arm automatically and cognitively controlled, or is that what we're suggesting?
Well, I mean, I suppose it probably depends on the complexity of the task. I mean,
There'd be some automatic control of the upper limbs when you're moving around, because you obviously have lower level reflex function, which is about saving responses, so there's sort of postural control integrated with gait and cognition. But that's not the case when you're looking at the cognitive dual task of course that
You were just looking at attention.
She looked at a cognitive dual task and a motor dual task. So the different types of dual tasks. So that wouldn't be the case in the cognitive dual task.
Yes.
It wouldn't explain that, the results that you see under that paradigm.
Yes, just had a few questions, but we'll go with one for now. And that is, you had the gait right map and you're reporting gait speed. Are you going to be looking at other variables?
Yeah, I did actually initially look at a lot of the other variables, and obviously I'd love to, and I did look a little bit at gait variability. Yeah, I mean, I thought that gait speed was the best variable to look at. And initially I did look at stride time, obviously from a cognitive perspective, and all the temporal measures I would be more interested in. So I suppose stride time I did look at a little bit, but gait speed was always, I suppose, the one that I was clung to most. And yeah, I mean, that is something that's huge from education. There's an awful lot to look at, but from the point of view of specific analysis that I did, I wouldn't have, it would have been early on, and I wouldn't have adjusted for covariates, so I can't really talk about the differences between those and gait speed. But I would love to look at that.
Actually, I may as well follow up with a second, and that is, with your dual task, in your remarks at the end, you mentioned you'd like to know more about the compensation aspect. What do you think the nature of that compensation is that you'd like to look at?
Well, I mean, I suppose, like you were saying, how do you perhaps do you compensate with, similar to your prioritization, do you compensate by doing poorly on your cognitive task? It's not so much a priority of task, it's more something that I suppose naturally happens, or compensations that occur due to other ailments perhaps you may have as an older person, or someone with a problem. So there's only so many things that you can adjust for or take, but I mean there's lots of different reasons, I suppose, where people slow down or do poorly on a test. But I mainly meant that link with the prioritization.
Okay.
Yeah, but not an explicit fact that someone had a strategy to prioritize more, that they just happened to compensate during.
Sue?
Thanks, Isabelle. I was curious about the kind of heterogeneity of cognitive response depending on your baseline or on your cognitive capacity. So you said that people who had high cognitive function under the dual task, they would be accessing more with their spatial features of the mocker. I guess you took that from the mocker.
Yes, yeah. That I did. That is hard to interpret.
I was curious as to.
So you could take you could take that two different ways. Yeah. I think, but I think what it does show is that there's different strategies, or that people who have different cognitive groups shouldn't have a blanket intervention. You know, there needs to be different interventions for different cognitive groups, as you were showing in your
So do you think that people with good cognition, it's like the visuospatial, they had to have that reserve before they could access this more complex processing? Or your other interpretation is that because you've got good cognitive reserve, you can then access the very simple online correction through visuospatial tasks? Or are both those wrong?
Well, I suppose I kind of, what I took it from those with poor cognitive function had their MOCA correlated with their gait speed. And also they were, I suppose, recruiting an awful lot of different. But you're talking about the good. Those were good.
Yeah. Why that might be?
Why just the visual?
Yeah.
I mean, perhaps. I mean, that the task was. I suppose I don't. Perhaps they could only hazard a guess that perhaps the task was maybe they were also really focusing on it and they were doing well with both. But yeah, I'm not sure. And the orientation for those, and I think that's very interesting, that middle group, because is that the good people, you know, maybe will do Sudoku, or they do, you know, things at home, maybe they naturally go out and do that kind of thing, and then the kind of people tend to know how to maybe help or, you know, deal with the people with poor cognition. But what about the people in the middle that you can still do a lot to, still increase their reserve? But there was a negative effect there with orientation. So, I mean, it would be nice to see, I mean, perhaps it's another marker of dual task effect, perhaps there, which is something else. But yeah, I'm not entirely sure about the visuospatial executive. I kind of, the poor global cognition kind of came out straight away, and the other two were harder to interpret. I don't know, perhaps.
Oh yeah, this is a kind of global thing. Where is it all going? Can I just say, I think it's absolutely wonderful, all that, and you've cracked it. I know it's a really thorough investigation, but I'm looking for a big picture and all this. So you kind of hinted at it. So there's this study going on, forgive me for not knowing all about the TILDA, but those are so-called normal. But what I would be interested in is how you said these were biomarkers for early intervention if they've got cognitive decline, but we're also interested in reducing falls.
Yes. But I suppose depends on how you view why the causality of the fall.
Oh, I can appreciate that. That's a complex issue in itself.
Well, I mean, I suppose the hypothesis is if you increase motor performance, cognitive performance, you decrease the fall.
Yes. But then you introduce something really exciting about the virtual reality intervention and possibly a rehabilitation strategy as an intervention that could actually improve and potentially reduce falls, and if you could get a biomarker that says, or if everyone who's come into A&E with a falls should be assessed with a gait analysis to see if they're markedly outside your TILDA data normal population, so that then you could see if there's a cognitive reason for it, and then perhaps introduce some virtual reality rehabilitation and see if there's an effect. And there you've got a real financial benefit from early intervention, a quick, simple procedure. I'm not trying to avoid the all the psychological testing and everything, but that's what I'd be looking for. And is that well, maybe it's not your intention of doing research, but that's a very good financial outcome, isn't it? To save your population of a million people.
Yeah, I mean, obviously an intervention is a brilliant way to go. I mean, I suppose, I think there's a few going on within here. Yeah, I mean, this is research, but there's a true benefit to the people that are actually coming in every day, even if the results don't show it. There's a definite social improvement, or an improvement due to the social interaction. So but I mean, that is the idea with that intervention, to get these the target people for intervention, but using knowledge from research, find out who those target people are, and I suppose given that the global population is aging and that we I suppose less money I suppose to for the health system, given all the people that are growing older, we will have to do some sort of remote maybe training at home for those people who maybe aren't that critical. So I suppose the intervention comes in there as well, to allow people to not go through the hospital system, to allow people to maintain themselves at home, and it improves everybody. So perhaps you would have maybe those with poor and intermediate or poor and good global cognition doing virtual reality at home, and those with very poor global cognition only being the ones needing to come in and be assessed. Or, yeah, that is, or preferably no one getting to that stage.
I wondered if you had any issues with adherence to your VR program with anybody that had poor cognition. So one of our VR studies that we've been doing here has been quite difficult to sort of convey instructions. You have to be quite involved in repeating what's required and what you want them to do. And I wondered if you had a similar thing with your virtual reality intervention.
Yeah, I mean, I think you have levels as well, so that was a definite, really brilliant thing, because it meant that actually, and more so than I perhaps other studies that I've been involved in, where the person, it is actually self-selected to their levels. They're doing as well as they can. It is personalised to them, should I say, and that was brilliant. But yeah, there you will, I think for I don't know. Yeah, I mean, there are certain people maybe that it won't work for. There wasn't really, I mean, there wasn't really anyone that didn't pass the level 1, but there were people that continued on that level. But then there were also people that went through it really, really quickly, and maybe it wasn't high enough. We had to create new levels towards the end. Actually, I think on the 5th day, because we didn't think people would do that well. So there's both sides of the spectrum. So maybe it's not for everybody, or maybe there needs to be just single tasks for different people, or really complex games. I don't know, for other people. Yeah. But yeah, I thought the levels and the fact that you automatically went through the levels. It wasn't, you didn't need someone there to.
So it's more intuitive rather than being sort of prescribed.
Yeah. But yeah, I mean, a dual task, if you're doing and clicking things, it is going to be tricky. And but actually, technology wasn't a problem, which was great. We thought it might be, but yeah, it seemed to be okay with that aspect of it.
Okay, should we have one last question?
Just a question about TILDA itself being a longitudinal study. I was just wondering, when is the longitudinal being collected, and is gait and cognition part of that, and what do you really hope to be able to test? What do you think you'll find, and what are your hypotheses in terms of gait?
Well, I mean, I definitely think that looking at those with poor executive function and poor attention, and following them with, as well as those, if I could bring in a new dual task effect measure, and look at those with poor gait performance, whatever that measure may be, in conjunction with poor executive function, and follow that through as a predictor to decline. And that I suppose is what my hypothesis really is. And then following that also, if we could get some gait variability from that. That's what I kind of initially thought: gait speed, gait variability, and then executive function. But also, I mean, with the attention coming in as well, maybe. And the wave 3 of TILDA is being collected, so every second year it's in the clinic for 4 hours, and then each other year it's at home. So there is, I think, there is a timed walk, but there's not the gait assessment or the neuropsychological battery, and it's on the 3rd year, so it goes up to 10 years, hopefully. Yeah, so I'm really hoping to look at that data, yeah, and work on the hypotheses that I already have, and see if they come through in years to come, but also I suppose new measures as MRI and FNIRS in the new TILDA, there's a fast walk, and so it'd be interesting in just pushing the population that a little bit more than the motor task maybe, and then refining those dual task effect measures with more information that we're going to get.
Okay, thank you very much. I'd like to